Welcome to the Deep Dive, the show that cuts through the noise and gets you straight to the core of what's important. You're probably already navigating the cloud every single day, streaming shows, working remotely. But beyond that buzzword, what's really driving this technology and what does it actually mean for how you work? So this deep dive is all about unraveling those layers. We're going to clarify the core concepts of cloud computing. Specifically focusing on its fundamental models and types. We've pulled insights from specialized IT white papers, academic research, and tech comparisons to bring this to you. We want to get right to the heart of it. Our mission here is to turn any confusion into, crystal clear understanding. Give you a solid mental map of the cloud so you can really grasp its potential and, speak its language. Okay, let's unpack this powerful force and see how it actually works.
It's fascinating, isn't it? How pervasive the cloud has become. It's not just tech, it's a whole economic shift. At its heart, cloud computing is really just a mode of on-demand computing resources. Think servers, apps, storage, supplied over the internet, usually on a pay-for-use basis. It's less about owning stuff and more like, renting IT like a utility.
Right, like electricity or water.
Exactly. Could be managed servers, could be internet-based applications, could be a mix of both.
So it's basically taking all those applications that a company used to run on its own computers, its own servers, and moving them off the premises onto these shared systems you get to through the internet. That sounds like a massive shift for IT departments. But for a business owner, does that mean giving up control or maybe inviting new risks?
Yeah. Oh, it absolutely transforms the operational model completely. Instead of that heavy upfront investment in buying and maintaining hardware that's your capital expenditure, CapEx, businesses can switch those costs to an operational expense, OpEx. You're paying only for what you consume. It really cuts down on server hosting and management costs, offers huge flexibility. And as for control and risk, that's exactly where the different service models come in. They offer different trade-offs.
Okay, that makes a lot of sense. So this utility approach that leads us to the different ways we can actually consume these services. This is where we hear those key terms, right? IaaS, PaaS, SaaS. It's all under this as-a-service idea.
Precisely. The core idea behind as-a-service is pretty straightforward. The cloud providers own, manage, and maintain all the underlying IT assets. As the customer, you just consume these services online, usually with a subscription or a pay-as-you-go plan.
Okay, but it feels like there must be a real spectrum of control there. How do they actually differ? What's on our plate versus what the vendor handles?
You've hit on a crucial point there. That, you can think them like a pyramid or maybe a stack. Different layers of control. They vary quite a bit in what you manage versus what the vendor takes care of. Generally, infrastructure as a service, IaaS, gives you the most control. Then you've got platform as a service, pay, which is sort of in the middle, and software as a service, SaaS, offers the least hands-on involvement from your side.
All right, let's start at the bottom of that pyramid then, the foundation. What exactly is infrastructure as a service?
So IaaS gives you on-demand access to the real foundational IT stuff. Compute power, storage, networking, the basic building blocks. It's often called a migration model because it's great for companies wanting to move existing applications and workloads to the cloud without, totally rebuilding them. Think of it like renting the raw infrastructure.
Okay, renting the infrastructure. So for IaaS, what parts are we managing and what does the vendor look after?
With IaaS, you're managing the higher layers. So the operating systems, your applications, any middleware, that software connecting things, runtime environments, and of course, your data. The vendor handles the core physical stuff, the actual servers, the storage systems, the network hardware, the virtualization layer, hypervisors, and the security of that physical infrastructure. Think AWS, Microsoft Azure, Google Compute Engine, IBM Cloud. Those are the big players here.
Gotcha. So what are the big upsides of going with IaaS then?
Oh, the advantages are pretty significant. First, you get the highest level of control and flexibility over your IT infrastructure. That's huge. It lets you scale resources up or down really easily, which is fantastic for, say, spiky workloads with unpredictable demand. It also slashes those big upfront capital costs and gives you quicker access to the latest tech. It's really perfect for those lift and shift migrations, just moving what you have into the cloud.
Understood. But I imagine there's still things to watch out for, downsides.
Absolutely, yeah. While it gets rid of the physical hardware burden, you still need skilled IT teams. They have to manage all those software layers you still control, and there's always that potential for vendor lock-in. If you customize heavily with one provider's specific services, moving later can be tricky.
Okay, we've laid the foundation with IaaS. Now, moving up that cloud pyramid, we get to the middle. Platform as a service, PaaS. How's that different?
Right. PaaS moves further up the stack. The vendor manages even more. It gives you a complete on-demand cloud platform that includes hardware, software infrastructure, everything needed for developing, running, maintaining, managing applications.
Yep.
People often call this one a build model.
A build model. Okay,
Yep.
so it's more about giving you the tools and the whole environment to build something, not just the raw parts. So what do we manage here, and what's the vendor handling?
With PaaS, your responsibility shrinks quite a bit. You're basically just managing your applications and your data. That's it. The vendor takes on the servers, network, storage, the operating system software, databases, middleware, runtimes, frameworks, even the development tools. Plus, they handle security, updates, backups for all those underlying layers. Think services like AWS, Elastic Beanstalk, Heroku, Google App Engine, Azure App Services.
Wow, that sounds like it really simplifies things for developers. Lets them focus on the code, not managing servers and databases.
It truly does, yeah. The advantages are a much simpler development process, and you can get new applications out the door faster, reduce time to market. It also means cost savings because you're not managing all that underlying infrastructure yourself. And this model gives developers more freedom to experiment with new tech, often with better built-in security. It really helps with agile development and DevOps practices.
Makes sense. What are the trade-offs with PaaS then? Where's the catch?
Well, the main trade-off is less control over the underlying infrastructure compared to IaaS. That's the big one. This can sometimes limit very specific customization options you might need. And similar to IaaS, you still have that potential for vendor lock-in, especially if you rely heavily on their specific proprietary services and APIs.
And where does PaaS really shine? What are the typical use cases?
PaaS gets used a lot for API development and management, agile development, setting up DevOps pipelines. It's excellent for cloud migration projects and building cloud-native apps, things like microservices, containers, serverless functions. Also really useful for Internet of Things or IoT applications, training enterprise AI models, and implementing hybrid cloud strategies.
Okay, so that brings us to the very top of our pyramid, the most hands-off option, SaaS, software as a service. This is probably the one most people listening are familiar with, even if they don't call it SaaS, right?
Indeed. Yes. SaaS is all about ready-to-use application software hosted in the cloud, delivered over the internet, usually on subscription. It's purely a consumption model. No. With SaaS, you manage very, very little. Typically just your user settings, permissions, maybe some minor admin controls. The vendor manages practically everything else, the applications, the data, runtime, middleware, OS, virtualization, servers, storage, networking, plus all the updates, security, and maintenance.
So it's just log in and go. Like using Gmail or Salesforce or Office 365. It's like having a superpower without needing to build the cape yourself.
Exactly. That's a great way to put it. Yeah. Other examples are Zoom, Dropbox, Slack, Canva, HubSpot, Trello, Asana, MailChimp, Notion, Monday.com, ClickUp, Freshdesk, Figma, Quixie, Zendesk. The list goes on and on. These are apps you probably use every day without even thinking about where they live or who's keeping them running.
And the benefits seem pretty obvious for the end user, right? Convenience seems key.
Absolutely. You get universal access from pretty much any device with an internet connection. There are significant cost savings, no hardware to buy, no software to install or maintain on your end. Updates happen automatically, handled by the provider. Deployment is usually super fast. It's perfect for supporting a mobile workforce, and the costs are generally predictable, usually per user per month.
What should we be cautious about with SaaS, though? It sounds incredibly convenient, almost too good to be true sometimes. When does that simplicity become a limitation or maybe even a hidden cost?
That's a really good question. Yeah, you do have limited customization options. You're using a standard product, maybe with some configuration, but not deep changes. Data security is another key concern. You really have to trust the provider's security measures because they're holding your sensitive information. And lastly, and this can become a real hidden cost, there's this thing called SaaS sprawl. That's where companies end up adopting tons of different specialized SaaS tools, sometimes without much oversight. It leads to fragmented workflows, inefficiencies, and spiraling costs.
All right, SaaS sprawl. I can see how that could happen easily. So, okay, we've got this incredible spectrum of choice from building your own digital empire with IaaS to using a platform with PaaS to just logging in and getting work done with SaaS. But the cloud landscape, it's never static, is it? It keeps evolving. Beyond these foundational three, our sources highlight newer models emerging, constantly redefining as a service. And one that seems particularly relevant right now is container as a service, or CaaS. What's the deal with that?
That's right. CaaS is a An emerging model, yeah. It's specifically built for managing and deploying containers. Containers are these lightweight, portable packages. They bundle up an application and everything it needs to run all its dependencies. This ensures they run exactly the same way across different environments. Key things about CaaS are strong orchestration, automating deployment and management, often using tools like Kubernetes, dynamic scalability, and that consistent portability.
So it sounds like a step beyond virtual machines, maybe offering even more efficiency, like packing lighter for a trip.
Yes, that's a good analogy. The main advantages are enhanced portability. Your app really runs the same everywhere. Also, more efficient resource use because containers share the underlying OS kernel, so there's less overhead than with full virtual machines. And yeah, dynamic scalability. It supports very agile development.
But I'm guessing it still comes with its own set of complexities,
Yeah,
like managing that orchestration layer.
it does, yeah. While it simplifies deployment compared to older methods, managing the orchestration system itself, like Kubernetes, and ensuring security within the containers, that still involves complexity. Examples of KS providers would be Google Kubernetes Engine, GKE, Amazon's Elastic Kubernetes Service, EKS, and Microsoft's Azure Kubernetes Service, AKS. If you look at the bigger picture, KS is really a new level of abstraction. It gives developers even more agility by standardizing how apps are packaged and deployed. It really paves the way for modern microservices architectures.
Okay, so we've unpacked what cloud computing is and how you can consume it through these different services. IaaS, PaaS, SaaS, and now CaaS. But that brings us to the next crucial question. Where does this cloud actually live? Let's dig into the different deployment models. Where do your digital assets actually reside?
Certainly, yeah, that's key. There are three main types of cloud deployment: public, private, and hybrid. And there's also a fourth one, maybe less common but important in certain contexts: community cloud.
Okay, let's start with public cloud. That sounds like what most people think of when they just hear the cloud, right? Amazon, Google, Microsoft.
It usually is, yes. In a public cloud, all the resources, servers, storage, networks are entirely hosted and operated by a third-party cloud provider like AWS, Azure, or Google Cloud. These resources are made available to the general public over the internet. Public clouds typically use a shared infrastructure pool. This means scalability, but maybe limited configuration options and some variability in performance or availability. They're generally best suited for less confidential information.
And then there's private cloud. Sounds like the opposite, more exclusive, more walled off.
It is, essentially. A private cloud infrastructure is dedicated solely to one specific organization. It could be built and managed internally by the organization's own IT department, or it could be managed by a third party but still dedicated just to them. The key thing is it's not shared with other organizations. This offers higher security, making it suitable for sensitive or confidential information. You have more control over data policies. The potential downside: accessibility might be more restricted compared to a public cloud.
So hybrid cloud sounds like trying to get the best of both worlds, mixing public and private.
In many cases, yes, that's the goal. A hybrid cloud is a true combination of two or more different clouds. Could be private, community, or public. They remain distinct entities, but they're bound together, usually by the technology that allows data and applications to be shared between them. This model offers advantages for multiple deployment types. You can leverage the scalability and cost-effectiveness of public clouds for less sensitive tasks, while keeping critical data secure in a private cloud. It's also really useful for handling unexpected workload surges. You can cloud burst, temporarily shift workloads from your private cloud to a public one when demand spikes.
Interesting. And what about that fourth one, community cloud? I hear that one less often.
Yeah, it's more specialized. A community cloud is a multi-tenant model, meaning it's shared, but only among several organizations that have similar requirements or concerns. Maybe they're in the same industry or have similar security needs. It can be governed and managed jointly by the participating organizations or by a third party. You can think of it as a sort of specialized hybrid, like a private cloud built for a specific group working towards common goals, maybe for industry collaborations or shared research projects.
Okay, this raises a really important question, though. With all these service models, IaaS to PaaS, SaaS, copy assess, and then these deployment models, public, private, hybrid, community, how do you even begin to choose? And what about the challenges? It seems like we're still facing hurdles in this constantly evolving cloud landscape. Choosing the right model isn't just about features, is it? It's about responsibility, managing complexity.
That's a crucial point, absolutely. While cloud computing has come incredibly far, there are still significant challenges, both at the design level and the implementation level. Architecturally, we still grapple with things like ensuring unification across different clouds, achieving true scalability, making components reusable. And then there are platform challenges dealing with all these different heterogeneous platforms, sometimes incompatible interfaces. It makes interoperability, getting different clouds to talk to each other smoothly, quite difficult sometimes.
So even though it's all broadly called the cloud, it doesn't always just play nicely together automatically. What about the practical day-to-day implementation issues, especially given the scale we're talking about?
Right. On the implementation side, you see both business and technical hurdles. From a business angle, rising data center energy costs are a real concern. That's driving a big push for energy efficiency, smart metering, and data centers. There are also reliability concerns, especially around choosing the right service provider, one that can genuinely meet your specific performance and uptime needs. Technically, security is still a massive area of focus. That covers everything from the underlying technology vulnerabilities to how security is defined and enforced in service level agreements or SLAs. And performance can still be an issue too. You can run into interference between different tenants on shared infrastructure, or inefficiencies from idle instances you're still paying for.
It's clear that while the cloud offers just immense benefits, it's definitely not without its complexities and ongoing challenges. It's also pretty fascinating to look back at how far cloud tech has actually come. From what I understand, it wasn't invented overnight, right? It has a longer history.
Indeed, it does. Yeah, cloud computing isn't some brand new invention. It's really the culmination of decades of technological evolution. You can trace its roots way back to the emergence of the first big data centers in the 1940s, then through things like time sharing in the 60s, grid computing, distributed computing in the 80s and 90s, all leading up to what we started calling the rise of the cloud around the year 2000.
Wow, that's a pretty rapid acceleration in the later stages. So looking back at our source materials, what were some of the most striking predictions about how the cloud would fundamentally change things, especially looking ahead towards, say, 2020? What were people bracing for?
Well, starting around 2010, the sources were predicting this big migration, large enterprises really moving workloads en masse to the cloud. Alongside that, the rise of big data, the ability to process vast amounts of information in the cloud to get new insights. There was also this vision of IT in a box and commodity data services, making sophisticated IT capabilities much more accessible, almost off the shelf. And by 2020, the anticipation was that everything as a services would really become the dominant paradigm. That's a huge leap from the earlier e-business services of the 90s or even the IT as a service focus of the early 2000s.
Everything as a service. Okay. And what specific predictions did our sources make about how things would evolve from the user's perspective and maybe from the vendor's side as we approach 2020?
From the user's viewpoint, they predicted businesses would fundamentally change. Many would essentially become software companies themselves, with IT shifting from just back office support right to the front lines, creating core business value, application developers. They were expected to become kingmakers because their role in designing these customer-facing services was becoming so critical. Workload placement decisions were expected to shift more towards end users, or at least line of business managers. Think marketing departments, CMOs, having a much bigger say in IT spending and choices. There was also this prediction that private clouds would have their moment of truth, facing challenges like long setup times, internal politics hindering adoption, and the idea of cloud brokerage needing services to help manage multiple different cloud environments was expected to gain importance.
Like managing that complexity. And from the vendor side,
Yeah.
what were the big players anticipating, according to the sources?
Vendors foresaw Amazon Web Services, AWS, just continuing its relentless pace of innovation, building higher-level services on top of its core infrastructure, like AWS Kinesis for real-time data streaming. Google and Microsoft were expected to really step up their game, getting serious with competitive cloud offerings, leading to what one source called a version 2.0 battle royal. The importance of the ecosystem, that network effect you get with lots of third-party services plugging into a platform, was also highlighted as crucial for vendors. Hybrid cloud integration, especially through tools like VMware's offering at the time, was seen as vital for bridging on-premise and public clouds. And, interestingly, a pricing bloodbath in the public cloud market was predicted, with the major players competing fiercely on cost, likely leading to some consolidation.
So it wasn't just about more cloud, but really fundamental shifts in how it's built, sold, and consumed. What were the broader, maybe more technological predictions for how the cloud itself would change by 2020?
Yeah, technologically, sources predicted software becoming increasingly hardware agnostic, running in this highly abstracted space, with a big emphasis on modular software design. There was talk of social software, where the infrastructure itself would kind of automatically mold to the tasks needed. Commodity hardware, like designs from the Open Compute project, that Facebook led initiative to share data center designs, would become standard. Widespread use of low power processors, like ARM chips, in data centers was predicted, alongside much faster interconnects between servers hundreds of gigabits per second. Data centers themselves were envisioned becoming more like ecosystems, self managing, highly automated. Consolidation among cloud providers was seen as inevitable. And a generational shift was anticipated, where new CIOs coming in would just expect everything to be available as a service.
Yeah.
And the clouds would stratify beyond just IaaS, PaaS, SaaS into more specialized providers. That's a prediction we're definitely seeing play out today.
That stratification really brings us to the current landscape. So what does the market outlook and maybe revenue forecasts tell us now? Or what did they predict leading up to this point? And how is this new stack of specialized services emerging?
Well, one prediction cited in our sources from Forrester Research projected the global cloud market to grow incredibly fast from about $40.7 billion back in 2011 to a predicted $241 billion by 2020. That prediction also suggested the IaaS market might eventually peak and become more of a commodity, while SaaS would continue its rapid growth but might start nearing saturation in some areas. And today, we're absolutely seeing the market move beyond just those broad IaaS, PS, SaaS buckets. It's fragmenting into more specialized as-a-service categories. You hear about testing as a service, management or governance as a service, security as a service, database as a service, lots more. It shows this clear trend towards greater specialization, a more granular approach.
That stratification sounds both powerful, offering tailored solutions, but also potentially overwhelming. You mentioned SaaS sprawl earlier. Is this new stack and all these specialized services kind of contributing to that sprawl? And what's the fix?
That's an excellent connection. Yes, SaaS sprawl is a very real problem stemming from the specialization. With so many targeted SaaS tools available for every little task, organizations can easily end up with, dozens, maybe hundreds of different apps. This leads to tool fatigue for users, fragmented workflows where data doesn't flow easily, skyrocketing subscription costs, duplicated data sitting in different silos, and just an increased burden on IT trying to manage it all. It can actually become counterproductive, almost like a digital closet overflowing with single-use gadgets you never quite integrate.
Okay, so what's the solution then? How do you combat that sprawl? How do you rein it in?
Well, one powerful remedy that's emerged is the rise of low-code and no-code platforms. LC&C, as they're called. Tools like Quixy, mentioned in our sources, are specifically designed to address this. They allow businesses, even non-technical users, to build custom applications and automate workflows tailored exactly to their needs without needing extensive traditional coding. This approach helps consolidate tools because you can build functionalities yourself instead of buying yet another point solution. It also helps integrate existing systems, creating more unified digital ecosystems where data can actually flow. By connecting data from different sources and often leveraging built-in AI or analytics, these LC&C platforms can help organizations make smarter, faster decisions. They can really transform how businesses operate from the ground up.
That makes sense, building bridges instead of just buying more islands.
Yeah.
So for organizations listening, whether they're considering the cloud or looking to optimize their current setup, where should they focus their time and money based on all these insights?
Based on the trends and predictions in the sources, organizations should probably focus on, first, reorganizing and maybe strategically outplacing some data management tasks. Concentrating on PaaS capabilities, either building on PaaS or partnering with service companies strong in that area, seems crucial for future agility. Implementing centralized trust and identity management models becomes really important as you use more cloud services. There's also renewed value in applying service-oriented architecture, or SOA, patterns within the cloud context. Continued focus on mobile computing strategies is obviously key. We're also seeing the rise of home clouds, think personal cloud ecosystems like iCloud, creating new development opportunities and user expectations. And finally, the rise of cloud aggregators or broker services that help you manage and integrate multiple different cloud services seems like a valuable area to explore for simplifying complexity.
Okay, so for you listening right now, how do you actually navigate this complex landscape and make the right choices for your own business or project? What are the practical steps you should take?
Right, let's break it down. First, you absolutely have to clearly identify your specific business needs. What actual problem are you trying to solve with the cloud? Don't just adopt tech for tech's sake. Second, define your budget and think beyond just the monthly subscription factor and setup costs, potential training, ongoing management, and calculate the expected return on investment. Third, assess scalability and flexibility. Can this solution grow easily as your needs change? Can it scale down if needed? Fourth, check its integration capabilities. How well does it play with the tools you already use? Can you build that unified ecosystem we talked about? Avoid creating more silos. Fifth, prioritize security and compliance. Look closely at encryption methods, access controls, data residency, and whether it meets relevant industry regulations like GDPR or HIPAA-PAR. Sixth, evaluate the user experience. Is the interface intuitive? Will your team actually use it effectively? What kind of support does the vendor offer? Seventh, do your homework. Read reviews, look for case studies from businesses similar to yours. Eighth, always leverage free trials or demos whenever possible. Get hands-on experience before committing. Ninth, consider the vendor's reliability and their commitment to innovation. Are they stable? Do they have a good track record? Are they investing in future development? And finally, 10th, plan carefully for onboarding and implementation. Understand the time, resources, and change management required to get the solution adopted successfully.
This deep dive has really peeled back the layers on cloud computing. We've gone from the basic service models, IaaS, PaaS, SaaS, and deployment types, right through to emerging tech like CaaS, the challenges, the history, and those fascinating predictions. It's really clear that cloud computing isn't just a technological shift anymore. It's a fundamental change in how businesses operate, offering unprecedented flexibility, scalability, and potential cost efficiency.
Absolutely. And looking ahead, given this rapid evolution we've discussed and the predictions particularly around AI-driven automation and these increasingly specialized services, it really raises an important question for everyone listening. How might cloud computing fundamentally reshape not just how businesses operate in the next decade, but the very nature of employment itself? What specific skills will be most valuable? How might it impact you and your role? Something to think about.